Doing example number 2 on page 89, we're going to do it the same way as we did number 1 with the quadratic formula. So you need to make sure it's set equal to 0, which in this case it is. So you state your a value, which is the number in front of x squared. So in this case it's 2. B is the number in front of x, which is 4. And c is the number at the end, or the constant, which is -9. And we're going to need to plug into the quadratic formula, which is x equals -b plus minus the square root of b squared minus 4 times a times c, all over 2 times a. And all we're going to do is, instead of a, b, and c in the quadratic formula, we are going to plug in our values. So negative, instead of b, we're going to put a 4 plus minus the square root of b squared. So 4 squared minus 4 times a, which is 2, times c, which is -9, all over 2 times a, which is 2. So this math that's underneath the radical, you have to work out by hand. So off to the side, I'm going to work out that math. So 4 squared is 16. And then we're going to do 4 times 2 times -9. Well, 4 times 2 is 8 times -9. 8 times -9 is -72. And we're going to subtract them because there is subtraction here in the quadratic formula. So we're really doing 16 minus -72. When you subtract a negative, you're really adding. So we're doing 16 plus 72, and I have to do that vertically. 6 and 2 is 8, 1 and 7 is also 8. So this whole expression underneath the radical is going to become an 88. The -4 out front just became a -4, and your denominator 2 times 2 is also 4. So 88 is not a perfect square, so we have to factor tree that. So off to the side again, I'm going to factor tree 88. And you can put this scratch work anywhere on your paper. 4 and 22. 4 is 2 and 2. 22 is 2 and 11. We're taking a square root, so we're going to circle in pairs. I have a pair of 2's and nothing else. And we have a 2 and an 11 left over. So the -4 out front isn't going to change. We had a pair of 2's. So a 2 is going to come out front. Square root of 2 times 11 is still 22, all over 4. So once you simplify the radical, we have to reduce. So when you reduce, the number underneath the radical cannot be changed. So the only thing we're looking at reducing is -4, 2, and 4. So you have to figure out what is a number that goes into 4, 2, and 4. Well, they're all divisible by 2. And so we're just going to divide those by 2. So -4 divided by 2 is -2, plus minus. 2 divided by 2 is 1. Square root, that 22 is not going to change. And 4 divided by 2 is also 2. So this answer we have right here is not incorrect. I just want you to be aware that the 1 out in front of the radical is usually not going to be written. So what I have right here would be an appropriate answer for this problem. Showing you this plus minus really means that there's 2 answers. Now I've ran out of space on this slide, so you can go to the right or you can keep working down depending on how much room you have on your paper. So this plus minus means there's 2 answers. So there would be a -2 plus the square root of 22 over 2. and a negative 2 minus the square root of 22 over 2, in case you had to write out both of the answers. So because there is a radical left in this problem, you could not have solved this by factoring. So you might want to note that over here, that this would not have been factorable. Whereas number 1, because we ended up with 2 whole numbers in the end, you could have factored the original quadratic by using the reverse box method if you did not want to use the quadratic formula. Where number 2, if you would have tried factoring, it would not have worked, and you would have had to use the quadratic formula anyways. So make sure on page 89 you have both of these examples with all of the work that I showed, and all of this little scratch work should be on your paper somewhere so you can understand how we got the numbers and where we got them from.